Okay, Edson, take it away.
Okay, all right, thank you. Okay, I guess you can see me now. Okay, let me start. Okay, once again, thank you for joining this meetup. Like I'm going to be presenting something on writing custom functions in R. Functions are very, very important for any data science task because you'll find yourself in most cases, you will need to use them. So they are very, very important. Unfortunately, my slide is not sliding down here. All right. So what are functions? Functions are basically a chunk of code is used to accomplish specific tasks. The good thing about functions is that they are reusable, which means you can use it again and again and again. You can actually also share them with others. Fortunately, in R, we've got so many functions that we are already there, that we use functions like the mean function, the summary function, a lot of other functions that we use. But here we are saying you can also create your own custom functions. So that's basically what I'm going to be talking about, how to create your own custom functions. So first of all, we need to know just the syntax for a function in R, how you write a function in R. So a function in R is basically written like this. So you write the name of the function, So you give your function a name. It is encouraged that you give it a name which is a verb, so that it shows that it does something. Then you write the function. Then in parentheses, inside the parentheses, there can be arguments. So argument one, we'll have some examples where you can see how some of the arguments that you can have in a function. So you can have several arguments here in a function. So these are like the inputs of a function. Then inside these curly brackets, you write some code that does something, and that code should return something. So here there will be the return function at the end of the chunk here. So this will be your code chunk inside the curly brackets and your return function. Okay, so this part is called the body of the function. Inside the curly brackets is the body of the function. So let me move on to my next slide. So I want to go to RStudio and actually show with some examples how we create functions. So allow me to go to my RStudio. Okay, so I'm now in my RStudio. Should I increase the size or something? People can see. Is the size okay?
Just to let you know, we just see your slides, so we don't see our studio. I think you have to reshare.
Okay, all right. Okay, I think I'm now on the RStudio.
Yeah, it's coming up now.
It's fine. Is the font
it's
fine?
starting to share. It's starting to share. So we'll give it a second.
Okay, all right.
So yeah, we can see our studio now. So I'll let you take it away.
Okay, all right. Okay, so let me start so I'll start with just a simple function, which is here. Like I said, this is how we write a function, write the name of the function. So there's my name of the function. And then we assign it to a function code function. So function, then yes, the argument is x, and inside the function there is y is equal to x plus 1, and is going to return 1. So that's how we write. I've been kicked out, so let me reshare my screen. Okay. I can see some people are saying they can't hear me.
Can hear you now.
You can hear me, okay.
And they are saying maybe you can switch off your video. Maybe it can help.
Or maybe it can help. Okay, all right. So, okay. I guess I can continue now. So I was on this first example where this is the function. So you write function and then what the function does inside the curly brackets, and then it returns. We are going to return this value y for our function. So let me run it. Let me run this function that I've just on my script here. Okay, I've run it. So here's the function. So when you run a function, you can call a function. So this function has got argument x, which means we can put any value of x here, and then it should return something. Suppose we in our function, this function. So let me write it. So you write here, we are calling the function. So you call if I write the name of it, just like the functions that we use in that are in R, you just call your function, and then if you put your cursor there, you can even find the arguments that it takes. So this function takes the argument x. So let's say x is 1. Let's say I put a 1 for my x and see what will be the output. Okay, the output is here. So the output is a 2, as you can see, which means our function is working. If you put 1 here, which means 1 plus 1 is equal to 2. So we can even try another argument. Let's say our x is equal to 4. Let's see. Okay. Okay, if our x is equal to 4, our output is 5. So which means our function is okay. Okay. So here in this function, there was only one argument. Our function was taking one argument x, but you can have a function that takes several arguments. Here's another example of a function that can take several arguments. Let's say I want to sum two numbers, to add two numbers. So this function is going to take two arguments, a and b. And what my function is going to do is going to sum, to have a sum of a plus b, and it's going to return the sum of, return this sum. Okay, so we can run this function, and give it some arguments. So this is some numbers. So let it sum 2 and 3. So 2 and 3, then we run it. It must give us a 5. Yes, fine. So our function is giving us a 5, which means it's working properly. Okay, also remember that in R, you can also, when you're putting arguments, you can also write the names of the arguments, like A is equal to 2, B is equal to 3. Still fine. This, you still get the answer. Okay. If you don't write the argument names, you must make sure that when you write the numbers, the arguments, they are in the order. They are in the same order as your argument names. So let's say you want A to be 2 and B to be 3. You must write 2 first and 3 next, because our function is A, B in the same order. But if you are going to write the argument names, it doesn't matter, the order doesn't matter. You can say B is equal to 5 and write A the other side. A is equal to 2. Okay, so it will still return what you expect. Okay, so here's the function that can, so this function can take many, so you can put several arguments here depending on what you want your function to do. Okay, so a function can take any data structure. So it can be a vector, a list, or a data frame. So we can also use, let me use the first function that I created here, which is my first function, which has got y is got x plus 1. And what we want to do is to, for our argument x, for our function, we want to put this vector, my numbers, this vector. So this vector has got 2, 3, 4. So you can actually put these numbers, this vector, into this function. So let's run this first. Okay, so we've run the vector, and if I put this my numbers into my function, it must give me output. Okay, so remember our function is y is equal to x plus 1. So each number here is being added by 1. So we expect to have a 3, a 4, and a 5. So as you can see, the output is 3, 4, 5 for the function. So you can actually input a list or a vector or single numbers or a data frame. Okay, we've already done this, so I'm going to skip this part. Okay, but the function can also have, it doesn't really mean that every function must have an argument. You can also have a function that doesn't have an argument at all. Like this function. This function is a function for greeting. Yeah, like we are greeting someone. So here's the function, no argument. It doesn't take any argument. And we want the function to print, hi, how are you? This function. So let me run this function and run the greeting and call the greeting function to see what it will output. So it will output, hi, how are you? So this function doesn't take any arguments, and it still produces the output. That is, what is it that we want it to do in the function? What is it that you want it to do? So it will return that without you inputting any argument. Okay. Then a function can also have default arguments. So you can have a default argument in your function. So let's say I'm create a function that can calculate a new salary for employees. So I want this function to take two arguments, current salary, and I want it to increment the salary of each of an employee by 500. Let's say 500 pounds or US dollars. Okay, so I want it to increment the salary of each employee by 500. So this new salary is going to be the current salary plus the increment, and it should return the new salary. Okay, so I'm going to run this function, execute this function.
Sorry, I just checked. Has Edson got knocked out? There he's back.
I've been kicked out again, so I have to reshare. I'm not sure I was kicked out. Maybe someone can remind me. Can someone remind me where I was before I was kicked out?
We're talking about that function for the salary, and you were saying it's being incremented by 500 for every employee.
Okay, all right, thank you. Okay, so this function, the salary is being incremented by 500 for every employee. So if you call this function, because the default is 500 here, so the default, you write the argument, then you write the default value that you need for that argument. So the default is 500, so that's why the salary is being increased by, has been increased by 500. So it's going to be, the new salary is going to be 1,500 as this output shows. Okay. But these default arguments, you can overwrite them. It's possible to overwrite a default argument. Let's say I want to run another function so that I overwrite this default 500. Maybe the salary has been increased by 700. Maybe for a particular individual. So I want to overwrite this default. It's possible to overwrite it. So you still have your argument. So I'm going to write, maybe the current salary is still 1,000. Salary has not been increased by 500, but by maybe 700. So I can write 700 here in my. So this 700 is going to override the 500, which is already there. So let's run it and see what will be the output. So output will be 1,700. So that will be the output. Okay, so default arguments, the good thing about default argument is that it allows users, if they don't input an argument for that default value, it will use the default value unless they input something. So that's the good thing about default arguments. Okay, I guess we can move on. So let's now understand how a function in R is evaluated. So basically, a function in R, what it does is that when it is looking for variables, it checks variables that are first that are within the function, and then it goes outside the function. If it doesn't find the variable, it goes outside to look for the variable that has been assigned in the function. So it will go outside to the global environment. Okay, let's have an example and just see, and let's play around with this function. So we've got this function x squared. This function x squared, it just squares any value that we input, and it will return the square of that value. Okay, so let's say, so I'm gonna remove this first. Okay, so I'm going to remove. So here is the function here, x squared. So what I've done is that I've assigned x to be equal to 2, and I want to square that this value of x such that I expect to get a 4. So let's run it and see what happens. So what the function does is that inside here, as it evaluates, it looks for, because it takes the value x, so it looks for this value of x inside the function first. If it doesn't find it, then it can go outside. Once you can remind me again where I was.
You were just explaining your x squared function.
X squared function. Okay, all right. So this is the x squared function. So x has been assigned inside the function. So we expect this function to, for it to execute, it must look within the function first. If it doesn't find this input value x, it goes outside. So for now, this is inside, so we expect it to generate a 4. So let me run this function, x squared, and then call it. Okay, so we have assigned it a 2, but within the function. So we can just run it without putting any argument. We expect it to generate a 4. So okay, it's a bit slow because so as you can see, it has generated a 4. Let's try to do this. Let's check out this x is equal to 2 and check it outside the function, just up here. Just see what happens if we check it outside and write a 2 here. So let's run these 2 first. So we expect this function when it executes. So let's run it first. Okay, so we expect it to look up because it can't find the value of x inside this. So it should look outside in the global environment. It's going to find it here. So we must still get a 4 here if we run this. Okay, let's run it again. Something has gone wrong. Let's run this. Let's see what it generates. It's giving an error. Okay, let's see. We expect it to return a 9. Still complaining. It seems like you can't see the X in the environment. It's X. Okay. It's a bit slow. Can't see the X in the global environment. It's fine. Let me move on so that we don't delay. Then I'll try to find out what's really happening when people are asking questions. It must be able to see a variable which is outside, which has been outside the function. Okay, let's test something here. Let's assign this here. Okay. And then assign another value at the top. And see which one does it choose. So I'm gonna run this. Okay. So here we expect it to return a 9 because it must check inside before it goes outside. That's what it does. So it checks inside first before it goes outside. If I have this value below here, below this function, let's say below, I write F4 and then run this and then run this X is equal to 4 and then try to square. It should give me an error. It gives me an error because this is below this function. So the whole idea is that it looks inside the function first, then it goes outside to the global environment. This is referred to as the technical term which is used for this is called scoping. It's called scoping. Okay, let me move on. So you can reuse your functions. So if you want to reuse your functions, you can save your function in a script so that you can use it again and again and again. For that, we are going to use the source function to do that. Or you can create a package like the packages that we know for you to be able to reuse a function again and again. So let's have an example of using where you can just create a script. You can create a script and be able to use it, the function and again and again. So for this, let me go to this window. Okay, so remember our salary function. So what I want to do is I want to have this salary function, save it in a script so that I can reuse it again and again. So I've saved it in a file called salary function.r here. So let me run this function because I want to reuse it and reuse it, access it again and again. Okay, so I've run it. So I put it in a script like this. So this is my function. So I want to reuse this function whenever I do my tasks where I want to calculate the new salary for employees. So I go to I'm now working on another script, but I want to use this function that I created before and saved it in a script. So for you to access a function that we have saved in a script, what you do is you use the source function. So the source function will take the part of the script, In other words, where is it located? So you write the path. So that's its argument, the part of the script. So for my script, this was the path. So the best thing is to make sure that your script is inside the same working directory that you are having your new script, such that we have to use a relative path rather than an absolute path. So this is a relative path because this file with the script is in the same sort of folder as this script that I'm working on. So I've used a relative path. So I'm going to run this so that I access this function. So if you run it, what it does is that it's going to bring the salary function in our global environment such that you can access it. So I've run this source function. If I type, I must be able to see this function that I created, which is new salary. Okay, I think you can see it here. It's even written .global. It means it's now in my global environment and I can use it. So here it is. So I can use this function for another task. So it's already in my global environment, so I can use it. So that's how I call it. So let me use it in a data analysis task. So here I've created a data frame which has got the names of some employees and their current salaries. So here's my data frame. So let me run this and also run the data frame. Okay, so here's the output for my data frame. It has got the names of the employees and their current salaries. So let's say I want to apply a function that will increase the salary for each employee. So what I'm going to do is I'm going to create a new column which has got new salary. So this is how I create a new column. And I'm going to call the function new salary. And this function is going to take the current salary as the argument. So this is the argument name, current salary. And it's going to take the value, my current salary from my data frame. So to access this vector of current salary, I have to use the data frame name, a $, the current salary, which is this column, current salary. So that's how I access it. So if I run this, create a new column, and then run my new data frame, I should be able to see the new salary. So the new salary, so the salary has been increased by 500 for each employee, as you can see here, because the default value in our function, remember from our function when you're creating it, it is 500. So this is how you save. This is how you can save a function and actually reuse it again and again in your analysis task. So like I said, the other way is to create a package. So if you create a package, the good thing about the package is that you can actually share it with all other users. So the packages that we know, like the tidyverse, those are packages. So they are just functions which were created as well for all of us to use, just that they were shared. but otherwise the concept is the same. So here is just my basic introduction to writing custom functions. But there's more that we can learn here that we can do that I've left. Other things like how do you deal with errors, warnings, things like that, such that when your function is running, for example, you need to warn users that, or tell them that something's wrong here, there's been an error. There's been an error somewhere. So this is something that can be done on another day. This was just a basic introduction to writing custom functions. Some of the resources that we can use, there's an ebook written by Hadley Wickham. It's called Advanced Error Functions. You can use that way as well. It is a very good book on functions. You can also use it to learn how to write functions, including complex functions. Okay, otherwise, this is the end of my presentation. So for now, I can take questions. I'm not sure if I can stop sharing or I should leave. I can continue sharing while these people can ask questions while it's sharing my screen.
That's probably a good idea, yeah.
Okay, all right. So I can take questions now. If there's a question. I will share this script for some of you to follow my examples here. Okay. Let me go through the questions. I thought the moderator was going to go through the questions. Is Emmanuel still there?
I think Emmanuel's had to leave early.
Okay, all right.
Yeah.
Okay. Okay, I can see here that would you please send me all examples to my email? Yeah, I think I can do that. It's fine. What I'll do is that I'll share the link, my GitHub link, and you'll be able to see all these scripts. Okay, same request. Okay, someone is asking, can you explain the line number 46, x squared? Okay, let me go back to where there was x squared. Okay, this is a function that will just square any number that we input in your function. So we want it, if you write a 2, we want it to say 2, if you input 2, we want it to output 2 raised to power 2. That's what the function is doing. So that's basically what it does. So if you put an argument here like 2, we expect it to square it. If x is equal to 2, it must return 4. That's what basically what the function does. So if I run this, let me go back to this here, and I run it. Yes, you get a 4. So it's just a function that will square any value that you input, any number that we input. Okay, I'm not sure if you answered. Thank you, Olina, for writing the author here for the book that I was talking about, Advanced Arrow Functions. I'm not sure about it. I'm not sure if it's a question which is written via var1, var2 index. I'm not sure about that question. Maybe if the person can clarify again by typing the question again. Okay, and see some information here in the chart where there's a variable 1, variable 2, then there's the index. I need to get only variable 1, variable 2, I need to get only variable 1, variable 2, and the index. How to write the function. I'm not sure about the question here. Is the question asking how do you get the value for each case, like index number 1? You want to get all the data values for index number 1. I'm not really sure, but it is possible. You can write a function, but there are also functions that are already there in R that can help you select a specific data. So you can use the select function. You can use the select function from, I think it's from dplyr, or you can use the where you use the base arrow functions for selecting some values. So some of the things you may not really need to create your own functions if they are already there. So I'm not really sure about this question, like what exactly the information that you want from particular data, but it is possible. You can select specific values using a function. How is garbage collection done in R? I'm not sure about this question, or you mean errors or something like that. If it is errors, this is what I was saying. We will need another day to learn about how do you capture errors from your functions, or to warn users that you have not used the function properly. It's something that needs another presentation just on that alone. Would you mind showing how to create a package from the function? To be honest, I'm still learning how to create a package when you have written function. So I guess sooner or later we'll try to call another presenter to teach us how to create a package. But every package starts with knowing how to create functions. So this is the starting point. Releasing of unused memory. I'm not sure about this question, but like I said, this will be advanced Arrow functions. So we need another day to look at all those other aspects that we've left out. This was just a basic introduction.
Hi, this is Kevin here. I'm just going to chime in about the garbage collection. It is actually a very interesting subject, but I just don't think it can be covered properly in a quick question. It's a very interesting subject, so it's worth a good big long presentation.
Okay, all right. Okay, another one about creating packages. I think the organizers are here. We need to look for someone who can come, and maybe someone with the experience about creating packages and do a presentation of creating a package. I think that will be interesting for all of us. I think I've gone through all the questions here. I will take it back to the moderators.
I think we are done. Thank you very much, Mr. Edson. I don't know if there's anything else that we need to talk about. Anything else? Seems like the questions are over.
The questions are over. There's still someone asking a question, but I would guess it would be best to contact me separate, not on this platform, about your question,
Okay.
or any of our organizers, so that someone can help with this question that I can see on the chat, a new question.
Okay. Thank you very much, everybody, for participating. And thank you, Mr. Edson, for presenting to
thank you.
us. We are grateful. Yeah.
All right, thank you.
Okay, I'll stop the recording. So.
All right, thank you.